Welcome, Year 7s, to another interesting chemistry lesson. I'm your teacher, Mr. Samuels. Now, before we move into today's lesson, we have a few tips for you while working at home. Try to work in a quiet area with little distraction. Read all slides and questions carefully. Remember, help is here if you get stuck. A teacher will be available to answer questions in normal school hours, 9 a.m. to 3 p.m. And remember, homework will need to be completed and posted by the deadline. Today's driving question. Now, this is a question that you should be able to answer by the end of the lesson. The question is how to use chromatography as a separating technique. Let's read that question again. How to use chromatography as a separating technique. Now, for your starter, choose your favorite section of the picture and write down as many colors as you can see. Now, be creative with your descriptions. Now, what I want you to do is to select any one of the three boxes on your screen and write as many colors as you can possibly see. Now, a little challenge. Which primary colors are in your section? Which secondary colors are in your section? Now, for those who do not remember your primary and secondary colors, here are the primary colors and secondary colors. Primary colors are red, blue, and yellow. Secondary colors are orange, purple, and green. Now, at the end of this activity, I want you to take a picture and send them over to me via my email address. Now, let's have a little recap. Now, remember, by the end of today's lesson, you should be able to answer this question: how to use chromatography as a separating technique. Now, a little recap. So far, we've looked at three separation techniques. Can you recall the three techniques that we've looked at so far? Filtering or filtration, evaporating or evaporation, and the last one, distillation. Now, you might remember from the last our previous lessons that we use different separation techniques based on the substances that we're trying to separate. All right, cool. Now, separation techniques. Today, you will learn a final separation technique called chromatography. Now, the word chrome derives from the Greek word chroma, which stands for color. You will also use your knowledge of solubility. Now, if you do not remember what the word solubility means, I'm going to now ask you to pause the video, go look for the word solubility before moving on, because we will be using this term in our lesson. Now, looking at the bottom of your screen, there is a picture of a prism. Now, we're seeing a beam or a white line going in, and as the beam or white line touches the prism, it splits into different colors. That's what chromatography basically is. You use one substance, and that one substance contains different pigments or solutions mixed together, and we use chromatography to find the individual components or color in that one substance. Now, this is what we call visible light. Yes, visible light. Once the light touches the prism separate the colors that's in white light. And that's why you're seeing the beautiful rainbow on your screen. Chromatography. Now, chromatography separates substance in a mixture. Remember that mixture is a substance containing particles that are not chemically bonded to each other, which means that they can be separated again. This technique relies on the substance being soluble in a solvent. Now, these are two words that we have used before, soluble and solvent. What are the meanings of these words? Soluble is a substance, means soluble means it can be dissolved in a liquid. Again, the word soluble means that it can be dissolved in a solvent. Now, a solvent is that bit that does the dissolving. In other words, it's a water or a liquid that does the dissolving of the soluble substance. Let's go back again. Let's go back. The technique relies on the substance being soluble in water. Now, if this substance is not soluble, which means that it is insoluble, we will not be able to separate it into different color. Once it is soluble in a water or in the water, we'll be able to separate the color into its different colors. Hope that makes sense. The term was first used in 1906 when the Russian botanist Mikhail Stivet wrote a paper about producing a colorful pattern of plant pigments. Yes, you are correct. Now, what you're seeing on the right of your screen is basically a substance that was taken from a plant, and they used chromatography to separate the different pigments that are found in that one solution or drop that they took from the plants. Now, as you can see, there are different colors, which means that there are different substances that are in plants. Now, there are one or two words there that you might be familiar with, chlorophyll A and chlorophyll B. We know that chlorophyll gives plants their green color. Now, there are a few steps that you must follow when carrying out this practical activity. Now, a small amount of solution is placed in the beaker. Now, the solution is normally water. That's the solvent that we use. All right. A solution is normally water, or the solvent is normally water that is placed in the beaker. Step two, on a piece of chromatography or filter paper, a pencil line is drawn. As you can see, to the right of your screen, you see pencil baseline. Now, the reason for using pencil is that pencil or graphite is insoluble in water, which simply means that it will not dissolve and interfere with your experiment. Three, spots of the substance are placed on the line spaced apart. Now, it is very important for us to separate these spots because guess what? The inks will separate and spread out into the paper, and we do not want the colors to be mixing as they go up the paper. The paper is placed into the beaker with a pencil line at the bottom. The solvent moves up the paper and the dyes begin to separate out. The spots on the chromatogram are analyzed and compared. And as you can see at the bottom of your screen, we have the example. Now, to the left of the screen, as you can see, the apparatuses that were used. We have a piece of wood, the pin, and of course, the paper. Now, in most cases, we can wrap the paper around the wood, or as you can see, we can also pin it to the piece of wood. Now, at the bottom of the paper, we have the ink spots that we need to find out the different colors that actually makes up the ink. We also have the solution, our solvent, our water that will be doing the dissolving of the ink, and we also have our beaker. To the right of the screen, we have the end product. Now, as you can see, the different colors that are in black ink: purple, blue, orange, red, and yellow. Who would have known? Did you know? Hmm. Now let's do a little activity. Now everyone knows Mr. Samuels, and yes, that's me. After a busy morning teaching, Mr. Samuels went to take his sandwich box out of the staff room fridge. To his horror, the box was completely empty and his favorite sandwich was missing. Attached to the top of his sandwich box was a joke written in black pen saying, "When do astronauts have dinner?" At lunchtime. Mm. This was very frustrating, but no fear, science is here. Now, Mr. Samuels could only think of three people who would do such a terrible thing and write such a terrible joke. He quickly extracted some of the ink from the joke, placed it into a solvent, and made a chromatogram. And it looked like this. Now, I took my tie off as I became comfortable because I am positive that I will find the person who took my sandwich. Ha ha ha. Now, Mr. Summers used the solving crimes using chromatography sheet from his previous lesson to make a chromatogram and to find out who stole the sandwich. Now, I have three suspects. Pen from suspect A, pen from suspect B, and pen from suspect C. Now, these are three of Mr. Samuel's closest friends in the department. Let's see who took his sandwich. Now, who ate the sandwich? That's a question we want to answer. Now, do you remember what the chromatogram looked like that Mr. Samuels got from the pen? If you can remember carefully, we'll find out who stole his sandwich. Now, was it Mrs. Swardo or Mr. Burns or Miss Burnett? Let's see who stole and ate his sandwich. Now, if we're remembering correctly, it was it the first one? No, it wasn't. Let's go over to Mr. Burns. Hmm, this looks very familiar. Let's go over to Miss Burnett. Guess what? It is Mr. Burns who ate Mr. Samuel's sandwich. Now we have found the culprit who ate my sandwich. Hmm. Now, as you can see, there are real world applications of using chromatography. Now, discussing peers, so you might need to find someone in your house and ask them a few questions. How might chromatography be used in crime scene investigations, in restoring old paintings, recovering stolen money, or food nutrition? Think about what we have just done and try to answer these four basic questions. You can grab anyone in your house gently and try to answer these questions. Again, how might chromatography be used in crime scene investigations, restoring old paintings, recovering stolen money, and in food nutrition? Right. Crime scene investigation use chromatography to separate blood samples, ink, and even powders from explosions. Well, yes, so they can find you from your blood, from the ink, or even from the powder that was used. Chromatography is very useful in restoring old painting, as the paints can be separated out to know which substances were used and whether any restoration has already taken place. This is how they can identify if a painting is fake or not. Yes, by looking at the ink. Now, you might see in the movies that some people might look at the photograph and know. Well, in some instances, you can look at the photograph and know if it's fake, but if not, if it's very close to the original document or original photograph, they can use chromatography to determine if this is an authentic photograph or image or painting, or if this is the fake. Now, food can be tested to see if they contain flavor or color additives, also to quantify the vitamins content. A red dye is often activated and explodes upon a large quantities of money when taken from banks. The dye creates a unique chromatogram that can be compared with suspect notes. Now, have you ever gone to the bank? I know I have, and I've given them a note. They normally use a highlighter which contains a specific ink and they rub it on the paper. Now, based on the color that comes out after rubbing the highlighter on the money, it identifies the money as being real or has been fake. So, again, if you have fake money, they will find out if it's fake or not. And please do not try this because it will not end nicely for you. So, again, ink, red dye, is often activated and explode upon large quantities of money taken from banks. The dye creates a unique chromatogram that can be compared with suspect notes. And also in food dyes, we can separate the colors in food dyes into the different colors that make them up. Now, let's see if we can attempt these questions. Number one, name each technique from A to D. We have one, two, three, four. A, B, C, D. Can you name each of the techniques? Pause the video and write them down. Question two. Decide which technique would you use to separate the mixtures in each situation, E to H. So E is separating salt from water. F is separating sand from water. G, separating mixtures in crude oil. And H, separating food dyes in sweet. Now pause the video and have a go. See you in 5 minutes. Welcome back. The answers are for A, filtering or filtration, B, chromatography, C, evaporation, and D, distillation. Answers part 2. Separating salt from water. We would use evaporation because the water will evaporate, leaving the formed crystals behind. Separating sand from water will use filtering or filtration because the water will pass through the filter paper, only leaving the sand or residue in the paper. Separating mixtures in crude oil, distillation. Crude oil contains different substances which contains different or have different melting points or boiling points. So the mixtures in crude oils will separate accordingly. And the final one, H, separating food dyes in sweets. Of course, we would use chromatography. I hope you guys answered those questions correctly. And if you got them wrong, please take a minute, pause the video, go back and make the necessary corrections before moving on. Now, what did we achieve today? We were able to create a chromatogram. We were able to explain how chromatography works. We can recognize the everyday uses of chromatography and we can identify different separation techniques. Now, credit goes out to Twinkle for providing us with free resources during these unprecedented times. So, again, big shout out and thank you to Twinkle. Please go to Google Classroom and complete the quiz. Until next time, it was fun teaching you guys. Keep safe.